The world is changing rapidly, especially on the side of software. You have companies like Google, Nvidia, Grammarly, Microsoft and Amazon all taking advantage of AI and machine learning algorithms to heavily automate tasks and control protocols without the input of human beings. We can follow or invest in these companies as well as use their products, but why not learn how they do what they do? In this video, I show you how you can begin to learn programming principles by setting up your machine to run Python 3. I also show you a basic logical script which is relatable to how machines take information as an input and then give it out as useful output. This is a multi-step process which involves installing 3 free programs. If you already have experience with running Python on your machine, in whatever form, then you don't have to follow the steps outlined in this tutorial. This tutorial is designed for the absolute beginner or someone who has dabbled in programming but has done it without the use of a comfortable home setup. The tutorial assumes that you'll be running Windows on your desktop, laptop or tablet. However, most of the methods here should translate into macOS or Linux with minor alterations. Nevertheless, let's crack on. The first program we are going to be downloading and installing is Anaconda. Anaconda is a free open source distribution of Python that enables your computer to essentially read and write Python without having to physically modify your computer's environmental variables. Previously, programming Python on your machine would require you to run a Python executable, installing Python directly into your system and modifying key paths. With Anaconda, this is not necessary. Anaconda also allows us to manage and modify packages in our Python distribution in a simplified manner. The next program we will download and install is PyCharm. PyCharm is an editor specifically for Python that enables us to develop our programming codes and scripts. Alternative editors are VS Code, Sublime, and Atom, to name a few. I personally have a preference for PyCharm because of its ease of use and its functionality. The last program we will download and install is Kite. Kite, or Kite AI, is an AI-powered coding assistant that enables us to write code efficiently whilst also acting as a repository for Python documentation on any module or function we may be working with. Typically as coders, we would Google certain modules or functions. Kite shortens this action by telling us straight away what a function or module does and also provides a couple of examples of how they are used. For Kite to actually work for us, we will need to install a plugin during our setup of PyCharm, which will enable Kite to work in tandem with our scripting or coding. This will be done during the setup of PyCharm. Install the programs in the order of Anaconda first, PyCharm second, and Kite last. When you have Anaconda installed, run it. The only action we are going to do in this part is to set up our Python environment. Setting up environments is important because it helps streamline our work and enables Python to run quickly for the tasks that we have set for it. Compare it to buildings. The way a building is built depends on the purpose it was built for. Are you commissioning a mansion? It will look extremely extravagant and have luxurious rooms and leisurely attachments. Some residential apartments, each unit will have a basic bedroom, kitchen, bathroom, living area and storage. Are you building a mall or some office space? The interior of the building will fit the purpose without being over-engineered or wasteful. Python is the same way. Python distributions come with a base set of modules installed, but it is up to the user to install extra modules pertaining to his or her need. Installing absolutely everything is wasteful because we won't use them. It will also slow down how fast Python loads and runs for us. So, we will create a learning environment for ourselves that contains a small number of extra modules and will enable us to write code that carries out a decent number of tasks. In the drop-down menu, we are going to switch to all and then click Update Index so that we can access the list of every Python module or package that Anaconda knows about. Search for NumPy and add it to your basket. Search for matplotlib and also add it to your basket. Search for SciPy and add it to your basket. Search for pandas and add it to your basket. Lastly, search for Beautiful Soup 4 and add it to your basket. After clicking apply and allowing Anaconda to install these packages to our new environment, our work here is done. Now we will install PyCharm onto our computer using the installer. Click 64-bit launcher and create associations.py. That's if you have a 64-bit launcher. If you have a 32-bit launcher, then it will show 32-bit launcher, and install as so. PyCharm is very particular and requires you to make a new project at startup. It is good practice to call it a meaningful name and save the project folder on either your desktop or a folder you can have easy access to. The next step is the most important step in this tutorial. We have to set our PyCharm project folder to run the environment that we created on Anaconda. On PyCharm, these settings are under interpreter, existing interpreter to be exact, which is basically asking what are you using to read or write Python. The location of our created environment exists in a subfolder of where we saved Anaconda. I saved Anaconda in my C drive, so the location of my environment is as shown. What you want is a special Python executable that is located in your environment folder. That is your special Python with the packages that you install. You can see now that PyCharm has attached the learning environment to our project. The next thing I'm going to do is that I'm going to check whether this has run correctly by creating a test Python file and calling the modules that we installed into our learning environment. If I can import NumPy, Pandas, SciPy, Matplotlib without the editor giving me any errors saying that it cannot find the packages, then it means that the attachment of our environment to our project folder has worked correctly. In this part, we are going to customize PyCharm with some useful plugins that will both make it look nicer as well as help us write good code. Install EduTools for access to some useful Python courses within PyCharm. Install Kite AI to assist our coding. We will still need to install the Kite program we downloaded in order to fully activate the plugin. Install Dart to assist our coding. Install Legacy Icon Pack to make PyCharm look nicer. Install Rainbow Brackets to make code in brackets look clearer. Install Sonar Lint to make fault finding easier. Install string manipulation for greater application and manipulation of strings. Install Key Promoter X to help us learn shortcuts. Install Material Theme UI to make PyCharm look nicer. Once finished, click apply and restart PyCharm. For the very last installation, we must install Kite. Kite will act in the background and act as our coding co-pilot. So now what we're going to do is that we are going to create our first program. Now usually first programs are simply hello world, print hello world. I find that to be not very educational, so I've opted for a reasonably interesting program which basically asks the user to input a number, and then the program will tell the user whether that number is an odd or even number. Now print is a function that automatically turns any input into a string and then prints it out. So you could ask to print a number, so say an integer number like 4 or 5, and put it inside the print function. The print function will automatically turn it into a string and then print it right back out to you in the console. The next thing I'm going to do is that I'm going to import the time module. Now the time module is a base package inside the Python distribution, and what it does is that it enables your program to sleep or to wait for a while without doing nothing. I'm putting it in this program to make the program a bit more interactive. Otherwise, every line of consecutive code will just be run as quickly as possible and it wouldn't be very interactive. Now here I create an object called a variable. The variable is assigned a value, and that value is given by the user input. The user input of which is called on by this input function. Here I'm just making the program a bit more interactive by turning the sleep command into a series of countdowns so that the program counts 3, 2, 1 from when it says hello and welcome to the script, thereby making it a bit more interactive. Now here we are going to use the print function again, but this time we're going to use it for the program to print us back out what we gave it, thereby making it even more interactive. Now I personally like to set all of my variables certain types just so that I remember what they are. So you can see here that I've stated that the number, the input that we gave in as a number, has to be an integer and only an integer. This is particularly important because the function that we are going to make, where it tells us whether a number is an odd or even number, only works with integers. So I'm covering my base very early on by making sure that the input can only be an integer. Coding is meant to be very logical, and in this part of the code I write a couple of logical statements where I've defined a new variable called odd_even, and I've said that it is equal to the number that we inputted earlier on acted on by the modulo function and 2. The modulo function is not actually a function, it's actually an operator. What it does is that it operates on a number, say in this case 2, and it divides the number before it by 2 and tells you whether there are any remainders. Now from logic, if any number is divided by 2 without any remainders, it is automatically an even number because 2 goes into it exactly. Any number that is divided by 2 and gives a remainder, then it is clearly an odd number because 2 does not go into it equally. And what I've done here is that I've written a couple of if statements. So if statements are conditionals. If a condition is met, then the computer carries out an action. And I've written 2 conditions where if the number odd even, so the result of the modulo acting on the number, if the result of that is equal to 0, then the number is even. If the result is anything else other than 0, then the number is clearly odd. Here I'm just testing the program to see how it works, and it works fine by telling us even numbers are even and odd numbers are odd. Thank you very much for staying to the end and sticking with the tutorial. I hope you learned a lot, and I hope this is the beginning of a new journey into coding. I shall see you in the next video.